to our first keynote of the day. Our speaker is Andreas Gal, the Vice President for Mobile for Mozilla. Andreas Gal joined Mozilla in 2008 to actually apply his dissertation research on trace compilation in practice and implement the first commercially launched just-in-time compiler for JavaScript together with Brendan Eich, the inventor of JavaScript. Over the last 4 years at Mozilla, Andreas has founded and co-founded a number of projects, including Mozilla's original TraceMonkey JavaScript just-in-time compiler, Mozilla's next-generation systems programming language, and the web engine Rust and Servo, PDF.js, and Shumway. In 2011, Andreas co-founded Firefox OS, Mozilla's web-based smartphone OS. He leads the development for Firefox OS and brought it to market in less than 2 years from its conception. Today, Firefox OS devices are available in several markets from several carriers and OEMs. He continues to be responsible for all technology and engineering aspects of the product, and he's going to present why and where WebRTC really matters. Thank you very much.
Thank you very much. All right, good morning. Good to be here in Chicago. I have not been here in quite a while. Thank you very much for the introduction. I will talk today about a bunch of different things. I will start off telling you a little bit about Mozilla for those of you who have not really had the chance to meet us before, and who we are and why we are and what we do and how we do it. And then I'm going to transition a little bit over into the web and some of the challenges the web is facing and why we believe that WebRTC is a particularly important part of solving those challenges. So first of all, let's talk a little bit about Mozilla. We are a fairly unusual entity. So we have a lot of different vendors here. We have Cisco and we have other vendors who are traditional companies. They're optimized for a specific purpose. They have shareholders, and their purpose is to make money for those shareholders. Mozilla is a very different entity. And we are competing in an environment that's really not optimized for entities like us. So we have to adopt in a certain way. Mozilla is a non-profit entity. We are a public non-profit for the public benefit. What makes us so different is that we are not just a set of people under some corporate roof. We are really a community. And this community is very large and much larger than some of the actual assets that this foundation has. So Mozilla is most known for Firefox, our browser product, which is used by some 500 million people or so. It's available in 80 languages. It has a very large developer community. So we have thousands of people who are writing software for Firefox, who are participant in developing Firefox as a browser and as a rendering engine. And in addition to this community, which is basically this loosely coupled community of people who are interested in open source browsers and interested in Mozilla technology, the Mozilla Foundation over time also created the Mozilla Corporation, and that's actually the entity that employs me. And the corporation is a much smaller subset of this community. It's essentially people the foundation affords to really accelerate and deepen and steer the development of the Mozilla project. We have around 850 employees or so. We are present in, I think, 15 countries currently with offices. But really, we are just kind of the core of this much wider community of people developing web technology and developing browsers. To understand what Mozilla is today and where we're coming from, it's important to understand a little bit of our history and how we were created. Mozilla was born around 2004 as essentially a dying act of Netscape Corporation. Netscape is pretty famous for being the first company to actually commercialize web technology. So the founder of Netscape was participant in developing some of the first open source web browsers, and he founded Netscape as a way to commercialize it and really accelerate the growth of the web as a technology area. And back then, Netscape was in a very unique position because they made the first browser people really started being able to use on their computers. And it was pretty much synonymous with the growth of the web and the emergence of the web as a technology field. So Netscape was this unique position where they would make this browser and they would let everyone use it for free for non-commercial purposes. And then you would have to have some sort of licensing agreement with Netscape if you were a commercial entity using Netscape in this commercial setting. So this was a very interesting business model. It grew Netscape exponentially. They very quickly started expanding and building a lot of web technology into Netscape, but also building a bunch of other products. It was a great business model. suddenly another company that was pretty famous back then and still fairly famous today, Microsoft, realized that if the web is growing at that pace and it's becoming so powerful and ubiquitous, then it would become a threat to Microsoft. So Microsoft entered the field of web browsers as well, very famously with Internet Explorer, which I'm sure many of you are familiar with, since it's so ubiquitous today on a desktop. And Microsoft started competing with Netscape in a way that Netscape really didn't expect and was not prepared for. As I said, Netscape was making the browser for free for everyone, as long as you were not using it commercially, but it was still making the browser very much in a traditional proprietary software fashion. So Netscape engineers would build the Netscape browser, closed source, and then it would package that, and you would have an ability to get that browser from somewhere in a box. And then you would not have to pay if you're a non-commercial user, but you would have to pay if you're a commercial user. This actually happens to be the business model that Microsoft was in at the same time as well, making proprietary software, and Microsoft was very, very good at that business model. On top of that, Microsoft also had the advantage that back then, and still in large parts today, Microsoft, of course, was also providing the operating system of choice, Windows, for many desktop computers. So what very quickly happened is that Microsoft introduced Internet Explorer, started bundling it with Windows, and not only made a pretty decent browser, but actually also used a couple interesting tricks to very quickly, over a very short period of time, push Netscape out of the market. The one aspect of that part of history that's most famously known is the fact that Netscape changed up the business model a little bit. So Netscape business model was, it's free for you for non-commercial use, and you have to pay for commercial use. The first thing that Microsoft did is that they made it free for non-commercial use and free for commercial use. That, of course, put Netscape in a bind because suddenly they were out of a revenue stream. But actually, there's a couple more aspects to that story that are actually much more interesting and more relevant to the talk today. What happened in parallel is that Microsoft, in addition to making the browser available for free and bundling it with Windows and using their strong market weight there to push their software, they also started something very sinister. Back then, there were not a lot of standards bodies around the web, and the web was simply more or less defined initially by what Netscape was doing. When Microsoft came in, they did the same thing. They started adding things to the web. However, they started adding things to the web in a way that only Microsoft could implement. And these two things together, that Microsoft very quickly achieved market share by bundling it with Windows and making it free, but also starting to embed technologies that only Microsoft knows how to implement, very suddenly gave Microsoft a very asymmetrical advantage. A very famous example was ActiveX. ActiveX is a piece of technology that Microsoft invented around this time, and it was essentially a way to make Windows native applications, like proprietary Windows applications based on proprietary Windows 32 API calls, to make this available on the web. And if you disregard for a second the really scary security mistakes that were made, the big drawback of ActiveX was that nobody else than Microsoft could possibly implement it, because there was a lot of Microsoft technology and APIs in there that only Microsoft knew how to use, only Microsoft had the tools to actually generate those things, and in many cases even Microsoft held patents on those technologies. So in essence, as Microsoft added this technology to their browser, they also more or less added it to the web, because there was really just two browsers, and Microsoft very quickly gained market share. So by adding it to their browser, they essentially were adding it to the web, and people were starting to use ActiveX controls all over the place. And Netscape very quickly became no longer competitive as a web browser, because now you could do things in IE with ActiveX controls you could not do in Netscape, and users would just vote with their feet and go and use the browser where the page works. But then at the same time, Netscape couldn't really catch up. They did not have the ability to add the same technology to their browser because, again, it was proprietary technology. So this was roughly the point at which Netscape then more or less went out of business in existence. And as a dying act of that corporation, Netscape realized that you can't really compete with Microsoft on Microsoft terms. If you're trying to compete with Microsoft making proprietary software, at least back then, but probably also today, it's a very bad business decision. They're very good at that business model. So Netscape realized that they have to go and really do a very disruptive change to the model. And at that point is when Netscape decided to embrace open source. They realized that by themselves, they have no chance of really competing with Microsoft. But if they create an open source project, which became the Mozilla open source project, they could create a community of people who are interested in this technology and making a web browser and making rendering engines. And then based off that open source project, Netscape was thinking that they could make their own proprietary version of the browser. So essentially, have a group of people develop the open source version, the Mozilla browser, and then also use that for Netscape's own browser. In essence, it's a way to kind of broaden your engineering base, get more people involved in making your software, and you can then maybe compete again. The first part of this experiment worked out. Netscape didn't really so much. So Mozilla is still around. The open source project today is around, and it's very healthy. Netscape's idea to make proprietary software out of this never really worked out for certain reasons that I don't have time to go into today. But what's important is the Netscape project the Mozilla project stuck around. So today, over the last 10 years or so, Mozilla grew into something that most of you are familiar with. So I assume that most of you have heard of Firefox, and actually roughly 1 in 3 here in this room are using it every day. Mozilla had to embrace a couple additional concepts that were very important to get us where we are today. The most important one is choice for the user. And this goes back to Netscape's experience. If you get in a market situation where only one corporation can implement technology that you need to make a competitive web browser, the user doesn't have choice. If you want to see the site, you have to use IE. The moment you're in that situation, it's very, very bad for the development of technology. And I'll be showing a couple of examples why that's the case. So that was one of the biggest focal points of Mozilla's work, is to guarantee choice for users. We want to make sure that there's always a choice you can make in the browser you use, and all the technology behind it for that has to be free. And the second one is innovation. Microsoft's ability to kind of lock the web into this Microsoft world was also predicated on people actually wanting to use capabilities that were not available in Netscape's browser. And there was simply a lack on Netscape's side to innovate quickly enough. If people want to use something only ActiveX offers, they will go and start using that. That's going to force your users to flop over and all use IE. So that was the second big strategic mistake that was made back then, is to not advance technology quickly enough, that there were standards and open approaches to something available. That's why people resorted to proprietary technology. So choice and innovation are those the two key pillars of Mozilla's technology, and that's how we are, of our foundation and our mission, and this is how we're trying to push forward technology. Where we are today is that in many markets we have around 30% market share, and I will talk a little bit about the other vendors in a second as well. In Europe, we're number 1 browser, in several parts of Asia as well, and in most other markets we're number 2 and number 3. So how did we get here though? Like, how did we get from the point where Netscape was essentially going out of business and IE was completely dominant? How did we get to this place where we have regained market share and we are now, again, a very competitive choice? To answer that, let's travel back in time a little bit. Who remembers IE6? Who had the unfortunate pleasure of using that? All right. What is the main thing you remember about using IE6? Bad, right? It sucked. It was terrible. That's the main thing everyone remembers. Why is that the case? So IE6 actually essentially was the height of the dominance of Microsoft. At some point of the IE6 history, Microsoft had something like 98% market share. And that, I claim, is the main reason that IE6 sucked. Because there was absolutely no reason for Microsoft to invest in it. IE6 was out there, people were using it, Microsoft was in a completely dominant position, and there was no reason to really advance that. And this is why IE6 stuck around for a really long time. If you look at the history even of Microsoft's browser numbers, you can see that IE6 was there for a very long time. And then at some point, Microsoft re-entered the game, and I will explain in a second why. And then the moment they re-entered, basically every year, Microsoft's making a new browser that's getting better. So IE6 was this time where Microsoft dominated the market, and they basically stopped developing the web and their web engine. And that's the time that Mozilla used to actually create Firefox and a competing browser alternative. Today, we are in a very different environment, as I said. Today, Mozilla, for example, has 30% market share or so, and there are several competitors. So today, if you want to go to a site like Amazon.com, you have a lot of different choice. You can use Firefox, of course, the browser we make, or you can use Chrome, which is a new browser a couple years ago Google came up with. There's Safari, of course, famously from Apple. Microsoft is back. There's IE, and it's no longer IE6. It's not like IE 10 or 11 or 12. And it's a fairly reasonable browser, considering it's coming from Microsoft, if you compare it to IE6. Until very recently, there was also Opera. Opera is sort of kind of getting out of this business. So Opera, in essence, these days, is wrapping Google Chrome browser into an Opera brand. But until recently, they used to have their own rendering engine as well. But even if you disregard Opera, there's at least 4 different separate implementations of the web and they're all harshly competing with each other. Yet, if you go to Amazon.com, it's any of these browsers, it all behaves the same. So you have the same abilities and the same capabilities across these different implementations by these different vendors. The reason that's possible is because in the middle we have standards. We have HTML5 and other open standards, including WebRTC, that define how these browsers interact with web content. This has created a very different environment. This is an environment where most of these vendors more or less have the same market share. And they are competing. And a single vendor can no longer simply put something in the web stack. 10 years ago or so, as I said, Microsoft added ActiveX to the web. And through that, very quickly was able to shift the web over to using ActiveX because it offered capabilities that the web natively didn't offer back then. And as a result, basically, all the users flocked to IE to be able to see that content. And this is how Microsoft, for quite some time, gained essentially a proprietary stronghold over the web. It's all the negative effects that we talked about. Today, it's a very different environment. So today, vendors are trying the same thing, but it doesn't work. So Google, for example, fairly recently introduced a new technology called NACL. NACL, we affectionately call ActiveG. It's essentially the same thing ActiveX is. It's the Google approach to ActiveX. It's a lot more safe, but it's the same idea that you can take native code and you can compile the web to this like new Google proposed proprietary NACL format. And Google added that, and she's using this, for example, today on Google properties. If you go to some of the Google implementations like Picasa, Google services, you can see there this ActiveX like x86 machine code running. It's essentially the same thing that happened 10 years ago. They offered some technology that one vendor is pushing very heavily, but it doesn't work. Nobody else has embraced it. The other browser vendors are very cool to it. We are not interested in adopting that. The reason for that is really twofold. First of all, there's no more one vendor with this like overwhelming market power where they can just simply push that, not even Google. But also, the much more important part is that there's actually open standards as an alternative. So this new ActiveG/NACL system doesn't offer any compelling advantages or what's possible today with open technology that's based on standards. So as a result, web authors are not really resorting to using NACL because there's many other ways you can achieve the same goal with the user that everyone can use. So the system is a very intricate system that's based on competition. And it really only works if there's multiple competitors and there's open standards to govern what really gets adopted in the web. A single vendor can no longer simply kind of cram something in a web stack. We need multiple vendors to agree on something. This is actually a really important piece of how web technology evolves. So this whole change over the last 10 years, where we went from like the Mozilla project and Netscape being very, very small and having almost no influence because Microsoft had this like 98% market rate. We went today to like having this even-keeled environment where there's multiple vendors, there's multiple implementations that are competing. The way we got here is really just market pressures. And as an example for that, I have this TraceMonkey project that I was introduced with. When I started with Mozilla, I was hired for a very specific purpose. This was around the time that Google introduced Chrome, or was about to introduce Chrome. So Mozilla knew that in a couple months from that time, Google would come out with Chrome, and we kind of heard through the grapevine that Chrome would be all about performance. And back then, at that time, the web actually was based on JavaScript, just as based on today, but JavaScript was actually a much slower language than it was today. Every single commercially shipping browser had only a JavaScript interpreter. And I was hired, since my background is compilers, to write the first really commercial JavaScript compiler. So we did that over a couple of months, and actually around the same time that Google launched Chrome, Mozilla introduced TraceMonkey, which was its first commercial JavaScript compiler. And this was very much based on this idea that if someone else comes out of the browser that implements the same standard, in this case JavaScript, but implements it better or faster, then Mozilla would get in a competitive disadvantage because users then could just say, well, it's really fast on Chrome, slow on Mozilla, so I can just switch to Chrome. So to keep this balance, it's very important that all these vendors are competing over the quality of implementation. We can't afford to be much behind. And I have actually a little graph here to also scientifically prove that to you. So about a year after we all started shipping just-in-time compilers, Google actually went and redid the just-in-time compiler they originally shipped in Chrome. Originally, when Google released Chrome, they engineered Chrome over 2 years, measuring against the then interpreter that was in Firefox. And then they didn't realize that during these 2 years where they were building this new just-in-time compiler, we actually built a just-in-time compiler as well. So at the time when actually Chrome came out, they came out with a big announcement how fast they are, but in reality they were basically as fast as we were because we did some work in the meantime as well. So Google played then, of course, the same game. They went back and redesigned the engine, made it even better, even faster. And at some point, Google came out with a new version of the JavaScript engine. This was the year after that, sometime in August. And you can see here some of the performance characteristics. So you can see here, higher is worse in this case here. The number at the very top here, the graph that looks really sad, that's Mozilla. So Google built a really good just-in-time compiler. It was really fast. You can see them on green here at the very bottom. And our engine was not dealing well with a particular benchmark set. The second interesting trick that Google did that's very smart, you should always remember this and apply the same approach if you ever have to do a just-in-time compiler, Google also released their own benchmark. That's really clever because, of course, they could optimize very well for the V8 bench. But the market forces don't really care. So there is a benchmark, V8 bench, where we were substantially slower than Chrome. We were like three times slower or so than Chrome in August. That's a really big marketing problem, I can tell you. So the press is immediately full. It's like, oh my God, Firefox is slow, Chrome is so fast. That's, of course, bad for us because we could immediately see users starting to use Chrome and switching away from Firefox, as they should. There's something better available, you should switch. That's the whole idea behind what we do. So as you can see here on the time scale, August is when this change happened, when a new engine came out. By the time that's October, we had essentially caught up with the competition. The way we have done that is we hired like 10 of the world's best compiler engineers and threw the best people and money at this problem that we could find. So you can see here how market forces forced us to very quickly respond and very quickly catch up. In the end, what you see often in browsers is that the state on the left is we're not stable. You cannot be worse than your competition for any prolonged period of time. We have to always get to a stable state where basically everyone is essentially around the same performance characteristics or the same quality characteristics. And this is really great because this means that it forces all the browser vendors to track whoever is the best. So whoever makes the best implementation of a technology sets a new standard. If you make something faster, everyone has to make it faster. And this is really important for the development of the web. It basically causes much better browser implementations. And in fact, Chrome entering the browser market several years ago really helped the quality of browsers. If you look at the performance characteristics of Firefox, it even made Firefox better because we had suddenly much more competition. Before Chrome, really our main competition was IE, which is even back then, especially back then, not a great browser. So the result is that you have these strong market forces forcing everyone to make browsers that are very competitive with each other. That's great. It's great for the users. It's great for the web. It really pushes technology ahead. So this is the main way how Mozilla, over the last 10 years, reshaped the way the web looks like and really reshaped desktop technology in the end. Today, the web browser is more or less everything that you interact with on a desktop. Your operating system, like Windows, is this thing. It's a bootloader, basically. It starts the machine and lets you go in the web browser. So far, it's really great, and it's a great success story, except if you think a little bit about what's happening in a more global view in a computing perspective. So our desktop machines don't look like this, but for many people who grow up today, they pretty much feel like this really old school thing. There's some predictions that over the next couple of years, 2 billion people will join the web and the online age. And almost all of them will not join with this piece of desktop hardware. They will all join with a mobile device. And that has various different reasons. Mobile devices are very ubiquitous. I could do a show of hands who has a smartphone in their pocket, and it's going to be almost 100% in this room. But surprisingly enough, even in other parts of the world, and especially in other parts of the world, these numbers are very high. So if you go, for example, to a very poor part of Africa, a lot of people have phones. Many of them don't have smartphones yet, and I will talk about that in a second, but many of them have a phone. It's a very basic piece of electronics, and you can very easily add computing to that. Whereas a desktop PC, or even just power in the house, many people don't have. So this old form of computing, a desktop PC, is really going out of fashion. That's actually a very significant problem for Mozilla. If you remember our mission and the way we went about that, Mozilla is not an advocacy organization. We don't come here and give talks to you about how you should be using the web because it's the right thing to do. When you're coming here and telling you about technology, what I want to show you in this talk is that you should use the web because it's awesome and it's better than everything else that you could possibly use. So we're not advocacy, we are pushing technology, we're making products. We're making products people want to use, and they choose voluntarily because they're simply superior. That, of course, is the problem, and people don't want to use desktop anymore. We have really great share of desktop browsers. We have a lot of influence of web technology on desktop, but this whole thing is going out of fashion. And you can see already the crossover point in many markets already happened, where people have more smartphones and more mobile devices that can access the web and desktop devices. So this is a very profound problem for Mozilla as a nonprofit foundation trying to influence technology, because it removes essentially the lever we have to influence technology. Computing has gone mobile over the last couple of years, not just in this market, but also in many other markets. And it's not just smartphones, but basically all aspects of your life. There's usually an app for that. There's some sort of like mobile computing content you can use, and it's really profound how much it changed things. It's like if you want to cook, there's a recipe app. If you're like waiting for a train, then an app can, the mobile device can give you access to some entertainment while you're waiting, or just like the time the train is departing, you can use your mobile device. So it's a very ubiquitous thing. Everyone is carrying it around, especially and including parts of the world where the desktop is not ubiquitous. However, if you look at the landscape, what's happening with mobile, if you compare it with a desktop, it's a very, very different landscape. And it's really scary if you remember back the environment I was describing with Microsoft. It's a little different than 10 years ago with Microsoft, but actually still very, very similar in many ways. If you start, if you look at today's ecosystems for smartphones, you will notice that in essence, they're very much the same as the Microsoft world was back then. 10 years ago, the desktop computing environment was really defined by Microsoft. You were using Microsoft languages, Microsoft technology, made by Microsoft, patented by Microsoft. And Microsoft was really leading and controlling the entire technology area on the web. On the desktop, I'm sorry. And on the web as well, so IE. And this is, of course, very bad for all the reasons we just discussed, because the moment a single company or a few companies control something, competition is going to be much less. If you look at the smartphone environment today, unfortunately, it looks exactly the same. Let's start with iOS. Apple very famously more or less defined the category of a successful smartphone, and they built a platform for that, iOS. And if you look at that platform, actually, it looks very, very similar to the Windows 32 platform 10 years ago. It's defined by Apple. You're using Apple proprietary languages, Objective-C, and Apple even prescribes you must use those languages. You're using Apple-defined APIs, Cocoa, that Apple has defined and only Apple knows how to implement. And there's really just one implementation of this platform that Apple sells you. Today, because we're in a more connected world, it's even scarier than back then, because actually there's more pieces to a successful platform today than just the client-side APIs and languages, and all those are controlled by Apple as well. So most of the services on these devices that you can monetize and you can generate revenue with, they're all controlled by Apple, like ad services and monetization on the device, all controlled by Apple. And because it's their platform and they own it and control it, they get to decide what goes on this platform and what doesn't. For example, very famously, Apple doesn't let you compete with them. If you have some sort of software that competes with what Apple does or wants to do, then you're not allowed to put that on a platform. The control mechanism for that is the App Store. Access to this platform must go through this funnel, that's the App Store. And Apple charges you if you want to sell something in the App Store, and they control what goes in the App Store. So you can already see that basically this is a very proprietary, locked-in system. And some people call this a silo. I like the term kind of like golden cage, because it's very shiny, it's nice, but still you're captured in it. And the reason you're captured is that once you buy an iOS device and you start buying content, you're really buying content that's written against Apple proprietary APIs and languages. And it's sold to you by Apple to the Apple Store. And once you bought that content through Apple, you're stuck. You can no longer go to the competition. There is competition. So a couple of years ago, Google came and said, we're going to save you from iOS. We're going to give you Android. And even though Google calls Android open source, or I guess available source, probably the better term there, it's supposed to be open, but if you look at it from a little distance, in the end, it's exactly the same. It's a Google platform. It's defined by Google technologies, by Dalvik and other pieces of Google technology and Google APIs. It's bound to Google services. So you have to use Google Search and a couple other services that Google offers on this platform. Google has a store. They charge you if you want to sell something there. And they control what content goes on the device. So in the end, really, Android is just as controlled as iOS. And even though there's 2 of these competitors now, it's not really a market that competes the same way as the web does. Because on iOS, only Apple defines technology, and on Google's side, only Google defines technology. So in essence, we are back to where we were 10 years ago on a desktop. And this is, of course, a really big problem for us as Mozilla. And that's also a Windows Phone. It's basically Microsoft's approach to do the same thing all over, but it's kind of roughly the same idea, Microsoft technologies and Microsoft services. This environment actually is really bad for a lot of different people. It's very bad for us because it's very hard for us to influence technology if you're locked out, just like everyone else here who doesn't work for any of these 3 companies. It's very bad for users. I already explained that piece, because once you buy content or have content available on these devices, it's bound to that proprietary technology. You can no longer switch to one of these other systems. So you're at the mercy of Apple, for example, if you have iOS. It's actually really bad for operators as well, because on these devices, the hardware itself doesn't make a lot of money, and the networks actually don't really make a lot of money either. What's really attractive is the services, and these providers of these platforms lock in the services. You cannot use any other services than they offer if they want to offer that service. So they can basically take away a big pie of the income that operators, network operators, would like to generate. Same for OEM and ODMs. Making a device, the hardware, is not really a great business to be in. You can see that in today's OEM market, because almost everyone except Apple and Samsung is losing money trying to make devices. There's different reasons for that. The biggest reason probably is that these platform owners have actually become very controlling. They tell you exactly, like, if you want to make an Android device, then you have to have the following hardware specifications and the following software you cannot change. And then often these OEMs are basically left with, they can change the plastic, the color of the plastic around it, or maybe put in a little bit less camera resolution. But they are very limited in what they can compete on. So it's very hard for them to compete and make money. Last but not least, it's also very bad for developers, actually, because developers have to write software for this, like, 2 or 3 different silos, and for each silo they have to reinvent completely the app they are writing, because the technology is so different. So how can we change this? We think that essentially all we have to do is apply the same recipe. There's a little bit different twists to this here, but in essence it's the same problem. There's 1 or 2 or 3, really realistically 2, companies that control the mobile technology space. They have these platforms, they control the technology, they control all the services, and all the content goes on those platforms. And we believe that this happened for the same reason it happened on a desktop. If you remember back ActiveX, what happened is that Microsoft made a technology that supplemented the web back then, and it allowed you to do things with ActiveX you couldn't do back then with HTML, and the reason people had embraced that. The same thing happened on mobile. Until 2 or 3 years ago, if you look at the mobile device, almost no capabilities on these mobile devices were really available to the web. So think back 2 years ago. Everything that makes a mobile device really interesting, all the interesting capabilities of the device were not available to HTML5. Telephony, touch detection, audio, location services, some way to drive device settings, contacts, NFC, camera, basically you name it. Any device capability, you name it, HTML didn't support it. This is, what happened basically is that all these browser vendors were so busy competing over desktop that they completely neglected making the necessary technology advancements in HTML5 to support these capabilities. So what people ended up doing is the same thing they did more than 10 years ago with ActiveX. These native platforms became available, iOS and Android, and people started making native applications for them because HTML5 was not able to compete in capabilities. So this, if you look today in the ecosystem, you see this like huge imbalance where all this content is made as native apps instead of HTML. It's really because of this reason, because browser vendors such as Mozilla did not focus enough on mobile and didn't provide the necessary APIs. The one big missing piece here today is telephony. So most of these APIs today here that you see here, we have solved. For the last 2 years, as you heard in my introduction, Mozilla, amongst others, we introduced a new smartphone operating system, Firefox OS, and it's completely based on HTML5. And it's very introducing that was very typical to the way we approach technology. Basically, 2 years ago, we realized you cannot build a smartphone with HTML5. As long as you cannot build a smartphone with HTML5, it's clearly not a competitive platform. If you cannot make a device that you can sell to people and they choose to use it and they like it, HTML5 is not a competitive platform on mobile. The best way to ensure that, the best way to measure that is, of course, let's make an HTML5-based smartphone. That's Firefox OS. You can, if you have not heard about it, you can Google around on the web and read a little bit about it. The idea behind Firefox OS is basically that we take HTML5 as a technology platform We add all the missing pieces that you need, and we make a smartphone with it. So on these Firefox OS devices that you can see videos and pictures of here in the media, they're completely built with HTML5. Every piece of software you interact with on a device is made with HTML5. Behind that is a rendering engine, the same rendering engine you use in Firefox on a desktop. And the whole device is essentially built on HTML5. The device is not being sold in the US and most Western markets because we are targeting emerging markets and those 2 billion people who are coming online next. But you can still find a bunch of information on it online if you're interested. Now, the one big piece we didn't address over the last 2 years, and that's what I'm here to talk about today, is telephony. We added the basic telephony capabilities here on this list here. So like the basic telephony stuff, like dialing 911 and a traditional, like, let's make a phone call to a phone number, that we had to implement, of course, to make a smartphone. But really, there's a lot of communication services that are still missing. And they're also missing across all these different devices that we ship software on today, and that's really what WebRTC is today. The reason that we think that WebRTC and communication services are so important is that if you take out your smartphone and look at your home screen, how often do you really touch the phone icon these days? I would say, I don't know what you use, but for me, it's like essentially never. 0 is probably a pretty good approximation of how many phone calls I make these days. I use some sort of SMS occasionally, and then the rest is really just like all the other stuff that's on my phone. And it doesn't really matter what kind of phone. Right? It's iOS or Android or Firefox OS, doesn't really matter. On these smartphone devices, they're really computing devices. They're communication devices, but not really with the traditional approach of like calling a landline. So this is where WebRTC comes in, and this is where it actually matters so much to us because it connects all these different device classes that we are making, and it also connects a lot of different use cases. What's particularly important for us about WebRTC is actually the pieces that are less obvious to it. So of course, WebRTC allows you to do things like video communication. And that's very obvious, and it's a very important replacement there because for a long time, video communication was the one piece of the web where there was no proper standards-based approaches available. And as like in history it always happens, and as I've described to you twice now, once you do that, once you neglect a certain technology area, what happens is kind of like this proprietary cancers grow in your OpenStack. And there's several of those you can pick which one you dislike the most, but they have all the same problems. There's a bunch of different plugins available for the browser that allow you to do real-time communication, but they're all made by proprietary vendors. They don't interoperate. And of course, that's really the opposite of how Mozilla would like to see the web develop. It's particularly bad because the moment it's proprietary technology like that, we don't really influence it anymore. If it's a Skype plugin or a Flash plugin that you use for communication, Mozilla essentially has zero influence on it. It's not based on standards. We have no chance of implementing it on our own. So we have no way of influencing the technology, and it really hinders our mission. So WebRTC is very exciting to see that happen, but that's almost the obvious use case. So I'm about to show you a couple of demos of our WebRTC implementation, and I will start with a very traditional, like, yes, we have video conferencing. But everyone has that, and that's actually for us almost the less exciting part. It's more like the baseline. You have to have that. We must close this gap where the web currently has no ability to do this natively, and you have to use some sort of plugins and native technology. But as you will see from our demos, it's actually not really the most critical part that I see, and I will show a couple of demos that highlight that. So let's see if we can make this work.
All right, so we're going to go ahead and demonstrate a multi-party WebRTC call here using the TalkBox demo. So the first thing I'm going to do is I'm going to go to the TalkBox website, and I know that Randall and Mira are already on there waiting for me to show up. First thing it's going to do is ask me for permission to use my microphone and my camera. Let's go ahead and do that.
Hey, Adam, how are you?
Hi, how are you doing?
Good. Good to see you, Adam.
All right. So it sounds excellent from where I am. Y'all both look pretty good.
You sound and look great, but you always do. But this is really nice.
Well, thank you.
It looks like it's like looking through a window, and the sound is wonderful. The Opus really makes a big difference when video conferencing. Yeah,
it sounds a lot better than a phone. The audio is just a whole lot better than I'm used to.
Yeah. It really feels like being there.
Yeah, on a classic phone, you can't tell the difference. If you aren't, without context, you can't tell the difference between sail and fail because of the audio codec. And you can actually tell that on something like this.
Yeah.
Yeah, this is way cool.
This is really nice. All right.
Yeah.
I love it.
This feels comfortable.
We should hold more of our meetings this way.
I think you're
I'm up
right.
for
Yeah,
it.
this is definitely.
WebRTC all the way.
Yeah. So, cool. All right. Well, thank you very much for showing off the demo, guys.
Okay, great.
Thanks, Adam.
Talk to y'all later.
See you at the next meeting. Bye.
Bye.
So you actually saw a couple of things here that you might not have seen. I want to point them out because really the obvious piece of people talking to each other online was not really the exciting one as far as I'm concerned. A couple of things that I think is really cool about WebRTC is that, first of all, you have seen that the service these guys used to talk to each other was not Mozilla. It was OpenTalk. It was one of the vendors that offers HTML-based communication services and a communication platform. So this is really profound, that you have a shared platform everyone can use across different browsers. And some of them actually were using other browsers than Firefox in our implementation of WebRTC. And you can have something like OpenTalk that can run on all these different platforms and interoperate. It's actually very important because the goal for us to advance the web is not really to make it possible for Mozilla to build new stuff. That's more like the proprietary role. What we would like to enable is to others to build cool services. So the main reason we are opposed to these closed platforms is because it hinders competition and people cannot make new services. And WebRTC is a very critical piece of that to open it up, to make it possible for everyone to build these technology pieces. The second one actually is very important from a security standpoint was the security dialogue that you have seen. A common problem is these proprietary technologies is that they have this very independent security frameworks. And WebRTC actually integrates into the browser security framework. So you saw the browser there ask for permission using the usual security door hangers browsers use to ask if it's okay to access the camera, for example, for communication purposes. So that stuff is pretty important. However, as I said, this kind of video communication and audio communication and chat to a degree is actually not even the piece that excites me most about WebRTC, and where we think that WebRTC is going to make the biggest contribution to the web stack. Let me show you another demo here. Other forms of communication are really important as well, and I will show you an example of that. So you see here is a 3D game that runs in the browser in HTML5 and JavaScript and WebGL, and it links different instances of this together using WebRTC and the WebRTC data channel. So you see some of the same people you saw on video here communicate with each other in a slightly different format. So each of them has a version of the browser running, and in the browser this HTML5 content is running, which is based in JavaScript and WebGL. And you can see that there's some chatting going on. So what these browser instances do is once they have loaded the page, they set up a data channel connection with each other, and the movement of the avatars here and the chat stuff is going back and forth. So this is actually really a very profound change that WebRTC brings to the web stack. So far, the web stack was very client-server based. And WebRTC enabled this kind of like more non-verbal communication as well. Let's see how long this goes here. All right. So we can watch them for 10 more seconds, kill each other. So this is a very important change to the way browsers communicate, because it removes the server as a central point of facilitating the communication. And in this case, for latency, it would not really be feasible to have all the traffic of all these different instances go through one server. So they actually set up data connections directly to each other, and then that's how the character movements are exchanged and data movement. The technology you're seeing here actually connects back to what I was saying earlier on ActiveX and ActiveG and trying to put native technologies in the browser. So the game you're seeing here actually is not written for HTML5 and JavaScript. It's actually a C++ game. And to make sure that you have this very advanced 3D gaming available on the web, and this is, as I said, pure HTML5 and JavaScript, you saw it start in the browser, we actually added some technology that allows you to take existing C++ code bases and you can compile them over to JavaScript and then run them in any browser. And this is really able to have very competitive experiences for game implementation, for example. So what you see here is a game engine by Epic that we have ported together with them using this framework. This is basically a large C++ code base. It's a commercial game engine that produces very high quality gaming. And they took one of these games, or one of the game demos, and compiled with this framework. And this is running in Firefox nightly, but this runs the same in Chrome and even in IE, using WebGL, which is the 3D abstraction that the web uses. skip the rest of the demo here. The last piece that I want to show you is that, of course, this is not limited to desktop. So far, all the demos I've shown do a bunch of cool stuff on desktop. But really, where WebRTC is going to be the most powerful is on mobile. And that's where we also intend to build our own systems and frameworks around it the most. I mentioned to you earlier that we are having this Firefox OS smartphone system that's now being sold in many parts of the world. And there, we will have a very close WebRTC connection to it. And we will also offer our own services and invite others to build services for it. Because, of course, on mobile devices is where WebRTC is the most powerful if it's kind of like audio and video communication. So there's a little demo here that we recorded that shows you a WebRTC call also on a mobile device.
We've been working hard to bring it to your Firefox OS phone. We're not finished yet, but today I'd like to show you some of the progress you've already made. I've got Firefox on my laptop up and connected to our test site. Now I'm going to take my new Geeks Phone Peak and call my laptop with it. Now you can see me twice, once through the laptop camera and once through the camera on my phone via WebRTC. Hi. Now let's see how things look on the phone. Not bad, eh? Thanks for watching. Stay tuned for more updates on our progress and timeline. Bye-bye.
So this is actually where many of the WebRTC implementations are the weakest. Everyone focused on a desktop first, WebRTC. So it doesn't matter really which vendor you choose. All the browsers today on mobile are nowhere near as competitive on the experience on mobile than they are on desktop. This is a very big focus area for us. So over the next couple of months, you will see tremendous improvements in our WebRTC implementation on mobile, since we have such a big focus on using it on our devices. So the main problems you encounter on mobile today is that simply performance is not good. Even in this video, you have seen that the frame rate actually was pretty low. And there's also some hardware problems around codecs. Many of these devices don't have a hardware encoder for the preferred format of WebRTC, which is the OpenVP8 encoder-decoder. So as a result of that, it's actually pretty difficult to achieve good performance these days. All right, this brings me to the end of my talk, and I heard we have a conference system where people can vote on questions. So I hope you have done that, and we'll see some of the questions here. And then I'm also happy to take additional questions from the audience. Thank you.
Thank you very much. That was great. Thanks.
Andreas, thanks so much. Just a reminder, if you want to use the app, it's rtc.cnf.io. Go to this presentation, and you can either ask a question or vote on one. We're going to take some from the floor as well. But as Carol's getting this set up.
I just wanted to tell you, I've been watching. I think people have been spellbound. There are only 2 questions up here with a vote of 3 and 2, so I think people have been so absorbed in the talk. But go ahead. Why don't you pose the questions?
So, good, I can see it in front of me and without having to turn around. So Google's a big sponsor for Mozilla, Andreas. How does that affect the decision-making in regards to WebRTC and Firefox?
So that's actually one of the common misconceptions about Mozilla. Google is not our sponsor. Google is a competitor. Google is also a business partner. This relates to the structure of Mozilla. At some point in Mozilla's history, the foundation created a company, the Mozilla Corporation, the entity I work for. And it's a very unusual entity because it has a regular tax structure like any regular corporation in the US and worldwide, and we pay regular income tax and everything. However, our only shareholder is a foundation. So you can think of it as a corporation that acts like a regular for-profit corporation, except that our only shareholder is a foundation that has a mission. So it's kind of like basically this kind of duality. And this corporation has an agreement with Google, and the agreement basically says that we ship Firefox. And by default on Firefox, the search that you do in the search bar goes to Google. And in return, Google offers us a small share of the revenue you generate from that search. So this is more or less a business deal. We drive traffic to Google. With that traffic, Google is making billions of dollars because there's so many people using Firefox. And in return, they give us some money. And that money, the corporation is then using to develop software in the interest of the foundation. This is a very symbiotic business relationship. We are a great way for Google and a very cheap way to drive traffic to them. and they are one of our biggest income sources. But this is not a sponsoring relationship. So Google is not giving us money because they like us competing with them. They're giving us money because we are a great way for them to make a lot of money. So in that sense, we're not really concerned about competing with Google, because as long as we have many users and we drive a lot of business to Google, we will have a very stable financial relationship with them. And there's also other competitors. There's Bing, for example, a large search engine that also would love to have 500 million more people being driven to them traffic-wise. So we're not particularly concerned about that piece. Where things get a little interesting is that, yes, we are very much strong competitors of Google in one way. On the other hand, we are also actually very closely collaborating. All of us who are working on Mozilla technology actually we have many close friends at Google and Apple and in the past at Opera, because often we also have to very closely collaborate. You saw this picture of these different vendors making browsers. Because nobody has a controlling market share, it's very difficult for anyone to bring in a new piece of technology. This is what stops ActiveX and ActiveG and Neckel from re-emerging. You actually need at least one or two of your competitors to walk with you to be able to establish new technology. So this also creates, at the same time, even though we are competing harshly, also a very friendly, collaborative environment where we very often talk to each other and coordinate technology. So Mozilla never introduces technology where we are not certain that at least one or two other competitors will embrace the technology with us. And then jointly we can have more than 50% market share, and then we can force the hand, basically, because then once 2 or 3 vendors have it, everyone else has to adopt it as well to not fall behind.
So the next one's been trending up as Andreas was answering the first question. But Andreas, do you expect ASM.js to remain quote-unquote Firefox only? Are you in touch with other browser developers, Google, Microsoft, et cetera, both in the near term and the midterm?
So actually, I could see the question with an eyeball. That's why I give you half the answer in my first question. Based on what I just said, you can already answer this yourself. If we have a piece of technology like ASM.js that only Firefox supports, it's useless. Nobody is going to use that. ASM.js is not going to succeed if it's not broadly available. The good news is that it is already broadly available. So the game I just showed you runs very well on Chrome as well. It runs on Safari. It runs on IE. So it runs everywhere already. This is what's so special about ASM.js. What ASM.js does is essentially a way to run C++ code in a web platform through JavaScript. However, it does that by translating to regular JavaScript. So it runs in any browser today. There's no extension you have to make. The only twist is that if the browser is aware of ASM.js, then it can implement specific optimizations. So ASM.js is basically a subset of JavaScript. It runs everywhere, but if you know about it in the browser, you can optimize for it specifically. And Mozilla has implemented these specific optimizations, and they make ASM.js code 2 or 3 times faster than regular JavaScript. Chrome today is already implementing similar optimizations as well. So today on Chrome, ASM.js code already runs very fast as well. We have close relationships with Google engineering team than with the other vendors. So I cannot tell you whether Microsoft is concretely working on this, but at least Microsoft R&D has talked very favorably about ASM.js. Also, because Google and Mozilla both are really good at running ASM.js code today, probably there's no chance for the other vendors. The other vendors have to implement it as well. Otherwise, you will have things like Epic Games on their website. You can play in the browser, but only if you have Google's browser or Mozilla's browser. And if you have Microsoft's browser or Apple's browser, it would tell you to download a different browser. So at this point, I think looking at the market forces and the fact that it's available everywhere, I think it's very likely that ASM.js is not only going to get adopted by everyone, but also actually we are trying to standardize it to TC39, which is the JavaScript standards body.
I think you probably could have read these yourself off the screen pretty easily, but how does Mozilla's mobile endeavors compare to those seen from Ubuntu with regard to opening up the mobile platform?
So I'm familiar with Ubuntu only from meeting Shuttleworth once and reading the press. So I can't really speak much about Ubuntu or some of the other efforts. There's like this Tizen effort, for example, by Samsung. All I can observe as an outside observer is they are using HTML5. That's cool. Like, we are a non-profit foundation. Our purpose is to eliminate proprietary technology and make mobile based on HTML5. And everyone else who seems to be doing something in this space is using HTML5 more or less. So that's great for us. We very much like what Ubuntu and Tizen are doing. We see it as a little bit different level. So we started Firefox OS 2 years ago, and we worked for 2 years to bring it to market. And in July this year, or June actually, we launched the first phones. We are now present, I think, in 14 countries and 2 regions of the world. And we are expanding that rapidly over the next couple of quarters. Whereas most of the existing other systems that have been talked about are really in a stage of like being proposed as an idea and not really being reality yet. This tracks back also to the way we see our role. We think that it's not enough if you just kind of make open source available and tell people to use it. We have to make a competitive product. So we see Firefox OS basically very much as an approach to capture market share, to make a great device people want to use in many markets, and then they're going to vote for that, and they're going to vote whether it's better and whether HTML5 is better. So in general, we are very supportive. If these other systems succeed, that's great for us, that's great for our mission. But our own efforts we see a little bit different because I think we are quite a bit further along.
So there were some of us who were having a conversation last night at dinner about a topic that's at least adjacent to this next one. What is your opinion of digital rights management in HTML5, or maybe in HTML, or excuse me, in HTML is the way it's written, but maybe in HTML5?
So the last 4 talks in a row in the last 2 weeks, I was asked about DRM, and all the talks are not about DRM at all. So it seems to be there's no way to escape the stage without this question being asked. So if you think about Mozilla as a nonprofit foundation arguing for like choice and like the end of these silos or golden cages, of course we're no fan of DRM. Don't make a mistake about that. But unfortunately, it's a fairly complex topic because there are content providers that make content available that people want to watch. And generally, I like to call this the Hollywood industry because that's really the biggest industry these days that still sticks to DRM. And it's their content, they own it. And they decide under what rules they make it available to you. And they have chosen, as of today, to make this content only available through DRM. And this is, of course, a problem for the web platform because the web platform does not support DRM. So what happens is the same story that happened 10 years ago with desktop and 2 years ago with mobile, or 3 years ago, that if it's not available on the web, people are going to find some proprietary way. And that's what's happening today. So today, the web has DRM, actually. It has it through Flash and Silverlight and other proprietary formats and APIs. So DRM is already today existing in the web, just in a really terrible way. A couple companies, including Netflix and Microsoft and Google, have proposed to replace the Flash plugin and the Silverlight plugin with a new kind of plugin. They want to standardize some pieces of it and then have the actual plugin be vendor proprietary. We, of course, don't support this. We think it's a bad idea. But we recognize that the content providers are in the end the ones who set the rules. So it's actually a very difficult topic for us to deal with. Well, our recommendation really would be to the Hollywood industry to take a look at the audio industry, which today already in large parts has embraced a very different business model. They give you content, streaming. If you buy it, you get it DRM free. They're so happy you bought it, and they're so happy about the extra revenue and you purchasing something, they just give it to you DRM free. And we are hoping that the Hollywood industry is going to come to the senses and embrace the same model because these DRM systems are really restrictive. They create the same cages where you are locked in with your content. You can't take your content to a different device. We've actually also, my R&D team has also proposed some very concrete technologies that we think would be a much better replacement than what Microsoft and Google and Netflix are floating right now with W3C as a proposal. Amongst others, there's new technology available that allows you to do very cheap watermarking using GPUs in the cloud. So you can stream content without these restrictive systems, but you can watermark it. And for the content provider, it's possible to track where the content is coming from. And if you are a large-scale abuser of the rights that they give you and you distribute it to people that you're not allowed to, they can find you, they can identify you, and they can deal with you through the courts. So we would find that a watermarking system like that gives people a much better balance of whatever rights the content owners want to enforce. At the same time, though, it doesn't create this very strange restrictive technologies. So our hope is that the industry over time is going to shift to this watermarking approach. Until then, it's going to be a pretty messy field with Flash and Silverlight and whatever Netscape and Google are up to these days.
Thanks. We're going to take a couple of questions from the floor. We're running a few minutes late, but I think we want to take questions from the floor, and we have the students here with the mics, so raise your hands if you'd like to pose a question. Aha, okay. We have a question here. And you're not going to need this.
All right. So my name is Christian. I work for Gallaudet at University of Washington, D.C., which specifically caters to people who are deaf and hard of hearing. So one concern I have about the developments in WebRTC is that we're in danger of building a new silo for those people in the mainstream and for those people who are outside of the mainstream. One very important communication medium for us is not only video, but also text. And I'm specifically talking about text that's integrated as part of the call and in real time. For instance, there's some people who sign and who type text to transmit it in real time back and forth. So that's different from tone-based IM. And there's another very large group of people who use their voice and who also read caption of the call in real time. And I'm concerned that if text is not a first-class medium in WebRTC, then we're just going to have more and more problems. So I'm wondering what's your take on this, and where do you see us going with this? We already have standards for real-time text communication, but the ones have us if they're not adopted in some form in WebRTC.
Thank you. So accessibility is a very critical concern to us, exactly for the reason that you said. If you don't support accessibility well, in the end, you create another silo for people who cannot access content. And this actually really aligns very well with what I said on my slides. We think that the audio and video parts of WebRTC are very important, but really the ability to exchange other forms of data, so data channels, is for me personally the most exciting part of WebRTC. It allows service providers to build exactly these kind of services. So we can build services, and people who build these services can very easily add additional communication methods on top of the audio and video stream, such as like carrying text exchange in parallel or doing sign language in parallel. So this is what really makes WebRTC so ubiquitous, that it doesn't lock you into just audio and video, but it allows you to have also data channel. And you have seen like the 3D avatars moving around. That's one form of communication through a data channel. The text that they were exchanging, that you probably couldn't see very well due to the resolution, that's also exchanged through a data channel. And then of course, any kind of like meta information that people need for accessibility purposes can also be carried through a data channel. So we think that that's very important, and we're creating a marketplace where everyone has the same technology available, and people can compete over this. And people have the choice to use systems that support this really well. I'm going to die here today.
Try not to kill our speakers. Are there more questions? There you
go. Firefox is big on Linux. Do you see Linux market share moving up?
So it's correct if we are big on Linux in the sense that many Linux machines use Firefox. But overall, actually, our biggest market by far is Microsoft Windows, probably followed by Mac, and then probably followed by mobile, and then followed by Linux. So the Linux desktop area has traditionally been very difficult for many reasons that would take a whole talk to explain. However, where Linux is really dominant these days is mobile. So Firefox OS, for example, is built on a Linux kernel. Android itself is built on a Linux kernel. Almost every alternative that's being proposed to these systems that you briefly mentioned in a previous question, they are also all based on a Linux kernel. So Linux, through the emergence of mobile and through the shift into mobile, is making a really big comeback, even though on a desktop it didn't work out as well. In theory, I don't see why the desktop shouldn't really also shift more strongly to Linux. We have already seen that some vendors started offering Firefox OS-based kind of tabletop devices and TV devices. Those might, in some markets, take over the new role of the desktop. So maybe, so these kind of like integrated devices where Linux is very strong, you will see more Linux deployment on non-mobile devices as well. But for the time being, I think Linux strength is really on mobile, where essentially, if it's not iOS, it's Linux, and there's very few exceptions to that.
I think we can take one more question.
Hi. My question is about...
What?
Hi, my name is Dai, I'm a student of IIT. My question is about the Firefox Web OS for the mobile. Yeah, and my fear is, will it be strong enough to have enough like application development? Won't it be weak like, for example, the BlackBerry? Yeah, so application development support, yeah. Because it said it's based on the HTML, so I was wondering how applications like will be able to be like built on that platform.
There's nothing wrong with it. It's showing. He needs to answer this question.
All right, I'm going to try to steal the microphone here. So the ecosystem, of course, is a very critical piece of any smartphone. And that's really where most attempts to make a new smartphone platform have failed, if they failed. If you look at WebOS, actually, and we don't call Firefox OS WebOS because HP and Palm forever tainted that term. WebOS actually was not really based on the web. It had HTML5 in there somewhere, but it was really based more around Palm and HP proprietary technology. And it failed because the ecosystem didn't scale. And Windows Phone right now is really struggling because the ecosystem didn't scale. It's very hard to convince developers to embrace this yet new proprietary platform. Like when Microsoft goes out and tries to convince people to make apps for Windows Phone, I can only imagine how hard that is. Like you have to learn a new technology, XNA and C# and whatever other proprietary hunks of technology Microsoft is in there. It's very, very hard to convince people. This is why most proposed proprietary smartphones simply don't work out. We actually believe there's no room for another proprietary system. It doesn't matter how hard you try, and Microsoft is about to prove that. Microsoft is a very big company, very good at making dev tools and all these things. If Microsoft is unable to make Windows Phone successful, it's essentially scientific proof that you can no longer add a third proprietary platform. Android and iOS are so dominant in the proprietary area, the only other alternative you have is the web. The reason for that is that we are not making a new platform. So for Firefox OS, for example, we have like all the top apps that you care about, like Twitter, Facebook, Yelp, all these things. And we didn't have to go to those developers and tell them, hey, like we have this new crazy thing called HTML5. Can you please make an app for it? They, of course, already have one, because everyone already has mobile HTML5 apps. So in the end, for Firefox OS, you don't develop Firefox OS apps. You just use your existing HTML5 content. In some cases, we have to go and do some improvements, and in many cases, this is around the APIs. We added new APIs. We're doing a lot of evangelism around standardizing them and getting people to use them to make sure that the mobile HTML5 experience is as compelling as the native experience. But in almost every case, these HTML5 apps already exist. The web is bigger than all these other platforms combined. There's already today millions and millions of web pages and web apps, and all those run on Firefox OS. So just on the day of launch already, we had a huge volume of ecosystem available to us because of all this HTML5 content. And the challenge for us is mostly around making the HTML5 mobile experience as compelling as like the native Android or iOS experience. But it's much less of a problem to getting access to content, which is the case for kind of alternative proprietary systems. So we're pretty hopeful that this is going to work out because HTML5 and the web already exist.
Okay, thank you.
Thank you very much.
Thank you very much. Thank you, Andreas. And let's go and make sure we're not the last people on the line for lunch. So. Okay, the next sessions will start at 1, so see you in the expo for lunch.